So curve sketching summary. What do we do step by step every single time we curve sketch? And depending on the question you have, sometimes you're allowed to skip steps, right? You know, if something's asking you find the max and min using the second derivative test, you can skip that first number line. But that being said, it's good to have sort of a process of this logically makes sense to do first, second, third, fourth, fifth, sixth. Then when you get these questions that ask you different parts of it, you could work yourself through the whole process and just pick out what you need. So to start off with, find all your intercepts. Y-intercept is super easy to find. You just plug in 0 for x. X-intercepts may or may not be easy to find. Like plugging in 0 for y might be something you can solve easily, might not be. Then you're going to find all asymptotes and non-permissible values. So if you have any non-permissible values, you're going to have a vertical asymptote anywhere where you divide by 0. And horizontal asymptotes, the limiting process, this is basically saying if I had an equation like this, I would have a horizontal asymptote at 1/4. The limiting process says if the powers are the same, then you're going to have an asymptote at the coefficients of those powers. Because as x gets really, really big, this is the only thing that's going to affect it. The other powers are less. They actually won't have an effect on it anymore. If you had an equation where the power is larger in your denominator, as x gets really, really big, the highest power is this x to the 7, and it's only in your denominator. And a really, really big number in your denominator will mean that you'll go to 0. And finally, if the biggest power is in your numerator, there will be no horizontal asymptote, because as x gets really big, that number in the top will get really big. It'll go off to positive or negative infinity. So find your intercepts, find your asymptotes. Those steps 1 and 2 for curve sketching is all stuff that you were originally introduced in grade 12. Then we start to get into our calculus. We want to find our stationary points and inflection points. So here, step 3 is basically where, to summarize the whole of step 3, it's where you do this step, where you find your derivative, set it equal to 0, and find out where it's increasing, decreasing. Then find your second derivative, find out where it's positive and negative, find concave up and concave down. So according to what I drew there, you would have a maximum at A, a minimum at B, an inflection point at C. And the notes here just define what the things are with notation. However, as soon as you make your sign diagrams, everything becomes clear. Like it's really clear from the sign diagram that it's a maximum at A. When I write f prime of x equals 0, f double prime of x is less than 0, this is the second derivative test, it's not quite as clear that, oh yeah, that's a maximum. Right away I can see it, right? So step 3 and 4 are both those increasing, decreasing the black and then the green. And step 5 as well. Step 3, 4, and 5 are basically that black line and the green line that I drew showing where something's increasing, decreasing to find max and min, and concave up and concave down. Once you have all of those points, you can sketch your curve. And remember, when you want to find a point on the actual curve, you need to plug that x value back into the original equation. So I've got the same sort of thing said again on this little review paper. And so what we'll do now is we will walk through a couple of examples of stuff that we've done so far, just to go through the steps. So first of all, do we have any x-intercepts and y-intercepts? Well, y-intercept is really easy. Plug in 0 for y. X-intercepts, you're going to have to factor. In this case, finding your x-intercepts straightforward as well. So you find your x-intercepts and y-intercepts. Step 2, do we have any asymptotes? No. We have no asymptotes horizontal, no non-permissible values. Step 2, we technically just skip. Okay? But in your head, you're still checking it. So if I was doing this question for someone and I just had to, if I wanted to curve sketch it quickly, I'd just skip step 2 because in my head I'd say, yeah, there's none. But it's still part of the process of thinking. Are there non-permissible values? Are there any asymptotes? So this, 1 and 2, that's review from grade 12. That's all stuff that you knew before. How to find x-intercepts, y-intercepts, how to find asymptotes. Yeah, okay. I'm going to do this next part just with you. Okay. Step 3, I would find my derivative. So looking at my original equation, I would get f prime of x is equal to 3x squared minus 4. I would set that equal to 0. And solve 4 equals 3x squared. X squared equals 4 over 3. X is equal to plus or minus 2 over root 3. I would plug that into my negative 2 over root 3 and 2 over root 3. Again, I kind of like labeling f prime of x beside this number line. What happens when I put in a very large number into f prime of x? Like 100. 100 squared is big. Times 3 is big. Subtract 4 really doesn't matter. It would still be positive here. If I tried a number between negative 2 root 3 and 2 root 3, like 0, into my derivative, can you see that I'll get negative 4? Negative. And if I tried a very large negative number, well, squaring it will make it positive. Times 3 will still be a big positive number. It'll still be positive here. So I know this section's increasing, then decreasing, then increasing. And I already know that at negative 2 root 3 and at 2 root 3, I would have a maximum at negative 2 root 3, a minimum at 2 root 3. This is called the first derivative test. Step 4, I would then find my second derivative. Second derivative would just be 6x. Set my second derivative equal to 0. Wow, I really like labeling that beside. Helps us remind us that I'm plugging something back into my second derivative. Yes? Have we needed our calculator so far? No. So usually curve sketching is not calculator because you could find everything else just by typing it into your graphing calculator, finding maximums and minimums. You wouldn't have to do any of this math. So if they want you to see, if they want to see this math, it's either non-calculator or they have to make it complicated enough that you can't use your calculator by using letters. So in this case, if I plug something less than 0, oh, I like to put my negative up higher to make my cyclopses. If I plug in less than 0, it's going to be negative. If I plug in something bigger to 0, it's going to be positive. So we now know that it's concave up and concave down. From this information, you now have enough to graph this. Now I've got the values there that were calculated from the calculator, the maximums and the minimums. This is plugging in negative 2 over root 3. And here we have, if we want to label those, this one was 2 over root 3. And plugging them back into the equation to get decimal values. So what have we labeled? We have all of our x-intercepts labeled first. That would be the very first thing you would label because you did that in step 1. Okay? In step 2, no asymptote. Step 3, you would have found the maximum and the minimum, and you would know where it's increasing, decreasing, increasing. Step 4, you would know that 0, 0 is an inflection point, so you can see that it changes from concave down to concave up. So now I'm going to give you about 15, 20 minutes to do the next 3, going through those steps. One thing that to notice here that I didn't do the second derivative test to find the maximum and minimum. But if you wanted to find out whether this was a maximum using the second derivative test, you would have still needed to go this far to find out it was equal to 0. And then you would go to your second derivative and plug in the negative 2 root 3 and find out it's negative. That tells you it's a maximum. Because if its first derivative is equal to 0 and the second derivative is concave down, the only possibility would be a maximum. And for 2 root 3, so you found your first derivative is equal to 0 at positive 2 root 3. You would know this is a minimum because when I plug in 2 root 3 into the second derivative, I get a positive number. And so if it's concave up and the first derivative is equal to 0, the only possibility is a minimum. So there's the graph for the second. Probably I would even flatten this out even more Because at 0, 0, you have a stationary point of inflection. How did you do? Pretty close. Just so that it's on the video, I can put up a bunch of the other stuff, how to find your X-intercepts, the fact that there's no asymptotes. This is actually the second derivative test. I'll scroll down here. That's the second derivative test. That's a step I usually skip and just go to my sign diagrams. I go there one, that sign diagram. Yeah. Right. Yeah, so that's where to get an estimate of where that is hard without a calculator. So usually on a calculator part, the numbers will, on a non-calculator part, the numbers will work out a little bit nicer. Okay? But what we're going to do right now is do the process as if we didn't have a calculator. And if you had to use a calculator for calculations of just finding those values, that's okay. Okay? What we're trying to avoid right now is just typing this whole thing into our calculator, finding maxes and mins easily that way, right? What are points that we can find easily with our calculator? Maxes, mins, X-intercepts. What aren't as easy with our calculator? The inflection point, right? There's not an easy way to find the inflection point directly from your calculator. You could make one, but it wouldn't be hard.
Can you explain how you found the stationary point of inflection?
Okay. The stationary point of inflection, I would find it, the easiest way to find it is from your sign diagram. As soon as your first derivative is 0, and it doesn't change from increasing to decreasing, that makes it a stationary point of inflection. For me, that's the easiest way to describe it. Now, the other thing that can show a stationary point of inflection is if the first derivative is 0, and at the second derivative, it changes from concave up to concave down, right? 0 is also a 0 of the second derivative. Then it's a stationary point of inflection. Because in my second derivative test, and really I should have my cyclopses here, negative, positive, negative, positive. So we can see that at each of these 3 points, we have inflection points because it changes concavity. And so if it changes concavity at 0, and 0 also happens to be a stationary point, then you know that you're going to have a stationary point of inflection. I'll move it back up to the graph. So as far as curve sketching goes, in the notes that you see here, I did the second derivative test just to review it. It's usually something you skip because you would go your first derivative and your sign diagram and you'd already know your maxes and mins. And then your second derivative and the sign diagram to find concavity. But I've put it in there just to remind us because it does often get skipped. The exam likes to ask at least a question or two to say, do you make sure that you know the second derivative test as well?